Hello, everyone, and thank you for joining. My name is Juan Scott. I'm the Executive Director of the 3MF Consortium. Today we had our first ever 3MF webinar, but we're primarily going to be talking about the design process, in this instance with Slicelab, a rollerblade using computational design. And we have, for this webinar, Arthur from Slicelab and DfAM from nTopology. So we'll kick things off. We are recording and we'll have questions towards the end of the webinar. You can put any questions you have in the chat or the Q&A now, and we'll have them all ready for towards the end. But I'd like to hand it over to Arthur to get started.
Hi, everyone. Thank you for joining. Very happy to be able to share this project with all of you. So Slicelab, we're a computational design studio, or just a design consultancy agency, however you want to call it. We've worked with computational design on product design, architecture for a combined 20 years between my partner and I. A lot of our work involves additive manufacturing. We've been using the technology for about 10 years now. I've worked with multiple clients using that technology, and this particular project, one way we like to work is have our client work fund our more fun research projects, we'll say, and this is one of them. We have worked in the past year or so on a few sports equipment pieces with additive manufacturing, working with Henkel Materials and Stratasys on some snowboard high back pieces and a scooter as well. And so with this one, I wanted to go to something that's kind of to our roots, our youth. And with the COVID, getting back to rollerblading, build something that was geared towards our use of it, and worked on these frames, which was a really fun project, and just research in software, modeling, computation. And I'll go kind of through the process briefly to explain how we went from the early design to where we are today. And yeah, and then welcome any questions. There we go. Okay. So this was first kind of renderings, looking at prototypes modeled mostly in Rhino, using sub-D and Grashopper to do some gyroid infill. We wanted to use that to keep the design pretty open instead of the more solid one you see at the bottom. But we wanted to have something that was more curvilinear and kind of using those sub-D modeling tools to make it less of the boxy, doing air quotes, engineered part. And so doing that, we used Crystalon for the first infill prototype, which worked okay, I think. But as we went further, it was a bit, we wanted to have more freedom in how we implemented it.
What are the limitations for Crystalon for you?
For us, I think what came to be then was the blending of the geometries together. The Crystalon is more like just an infill thing. And having that ability in nTop was kind of amazing. And I think just how fast it worked, just like it takes a lot of memory out of your computer working in Grashopper. Grashopper works only on like one CPU at a time. And so when you get starting to really fill those areas, it gets very slow and just time consuming to go through it. This was the first printed prototype. It was not tested or rolled on because it didn't feel like it was beefy enough. I don't know if you can see the camera. I can show them later. I have the parts with me. But we really liked the look and what it was giving as a product and what it came out to be. I think it's something that we hadn't seen in this particular product type. So we went back to the drawing board of it and then worked with the nTopology guys to push this further, going through topology optimization, which we had done very briefly same thing again with Grashopper before, but it was extremely time consuming, extremely slow, wasn't really working for us. With nTop, studying how we would apply the load cases and everything, we got to something that worked. It took a few trial and errors for sure. Chase at nTop was really helpful with that. And thank you, Chase. And then from that point on, us as designers, we like to use these softwares for what they're capable of, but then coming in with our kind of aesthetic background and design background, we took those results back into Rhino to model it and adapt it to the form we wanted, and then back again to nTop to do that gyroiding infill and also the blending.
How did you get the loads to the top up into nTopology? Like, how did you define them? What was the?
It was mostly based on, like, I guess my body weight and like our business partners' body weight. We're pretty heavy guys. So we had
strong, manly.
Strong. We'll say that. So we had basically the way the part is set up. I don't know if you can see my mouse.
Yeah.
So the way the loads were set up, if I remember correctly now, the top here was set up as a
Displacement. Yeah.
Displacement. So this one wasn't.
It's a static stress.
Static stress.
Yeah.
But then we had axial, like point loads, basically in between the axis here for the wheel, for each wheel. We had loads, and then the other thing we had is, because these are used for grinding, also that's what that space in the middle is. We had a load all along the surface here, a point load all along the surface at the bottom here, which is called the edge block, which you can basically hear.
Yeah.
All those surfaces here were with point loads on nodes, basically all throughout these. And so we had, and for each of those, we had actually done, because the top was, we assumed the top was the part not moving. So we had up loads and then side loads on all of the wheels as well.
How do you, because if you have a side load from both sides, they'll cancel each other out, theoretically, yeah?
Yeah, I think we ended up, that's what we noticed, and we ended up just using one side.
Okay.
And kind of seeing what that was doing, and then doing the other side, and then using mirror. We ended up doing I think the top up at the end, we ended up doing on a half.
Yeah. Okay.
And then mirrored the F mesh to get it.
Okay. So for those who haven't used topology optimization, if you do a load on both sides, which is equal, then you'll cancel each other out. And so what they're saying is you do the top up on one side as half through the X.
Yeah, you can see that. Yeah. The part in the final mesh is a mirror.
Yeah, and the mirror. Yeah.
Which is how we ended up doing it. Yeah, because we did figure out after putting all those loads in and everything that they were canceling each other out. So like, okay, maybe we need to go back.
Or do you think there is, and this is expanding way beyond, do you think there's a right foot, left foot bias you have in the design if you would take it a step further?
If we take it a step further, for sure. But I think, and I think it depends on also maybe the person, and then you start implementing it to like a person's writing style. We're not pros by any means, so I wouldn't look into that maybe for us. And I'm just kind of I know I'm a righty, so my right foot is going to be.
If you dig down, like a scene from Rocky 3 or something, where you're all hooked up and on a treadmill, rollerblading, as you're going around, have sensors on everything, and then do a feedback loop.
Yeah. But I think that would be interesting. The one thing that, and so then from that point on, we were really excited by some of the new rollerblades we had seen coming out as we got back into it, especially having done it 10, 15 years ago, seeing what the new stuff is out there. So this really inspired us to use the color printing and the MJF, because you'd still be able to get a functional part, but with color. So that's what inspired this marble one here. And then this one, it was really, once we started exploring nTop and understanding it more and understanding how the gyroiding was working, what kind of caught our eye was, wow, I can do booleans with gyroid walls very easily, which is something like outside of nTop, I don't think any software would be able to do. Any software we've used would be able to do that easily.
Do you want to talk about how it makes it possible to do those gyroid booleans in nTop? Do you want to touch on that, Deho?
I mean, from my end, it was understanding implicit modeling and how easy it makes these.
Yeah, we just use implicit technologies. So once it's all implicit, Boolean is basically doing the distance squares and putting those together into a one big equation.
Yeah. So for those who don't know nTop, it's an implicit-based modeling kernel, not using a mesh or a brep, which makes these booleans fast and possible.
And incredible to do, because what came out of it was we had basically this particular part that was printed and that's also I think the beauty of 3MF after to get it printed. That's a photo. That's a photo. That's not a rendering. That was the marble one. But what makes, I think, that's also the beauty of using the 3MF file is basically out of nTop we got 20 meshes. For the white part, it was one mesh that you see in this picture, and for the gray part, it was 19 meshes basically throughout. And the way we had done it, we had, without going too much into detail, we had made sure there's an overlap between the booleans and between those meshes, so that when we then put it together as one 3MF file, I can still apply different textures to the one group and to the one white mesh. While they're still overlapping, I can still send that basically as a print file that's ready to go. And that's how.
Yeah. And in this instance, it's a multi-color print, not multi-material. So if you're doing multi-material, you may want to have to think that even another step further, because the machine has to define which is going to be material A and which is material B. And then in a lot of instances with multi-material printers, the boundary between those two can become a problem because they don't bind correctly sometimes. And so we're seeing some people do like a jigsaw pattern between those surfaces as well, so it interlocks. Not jigsaw, but just like maybe even a noise gradient, so it's not a plane, a surface. So it's a noisier interoperability point. So then the mesh is going to get even bigger.
Right.
Yeah.
That's why we have volumetric extension.
Yes, volumetric extension.
Talk about it.
Yeah, so let's put a pin on the volumetric extension and talk about it after you've talked about the design process a bit more. Yeah.
Sure. So, but I think from a design process, that's a very quick overview. I mean, there was a lot of the topology optimization took a few trial and errors to get to something that also intuitively seemed like a lot of the first results were like, no, this is impossible. Like this wouldn't work at all. And I think at the end, it's just talking a bit about 3MF, where we're all here also today. What we really liked about the file format was, one, it was much lighter to start sending files to manufacturers to be able to get those checked really quickly. We did use a kind of a homebrew meshing system to reduce a lot of these meshes coming out, especially for this variant, which, as you can imagine, is like a gigabyte STL originally. So had to find ways to bring it down, but 3MF also helped with that. And then we could apply the texture, we could give a description to that, also apply some kind of copyright and licensing terms and things like that, which is, for us as designer, we find that like very valuable. Even though we did put those out for free for download, anybody can print the parts.
Not commercial.
But it's not for commercial use. For now, we don't plan on doing that. It's more of a research, but.
Okay, so there's a few things going on with the 3MF file. So first, the basic thing is about a quarter the size typically of an STL file because it's a more efficient way of communicating, and then it's compressed as well. The second is you can hold all the bodies in one single 3MF file container. So the container can hold multiple meshes, including color information. And then you can also define, depending on the software you're using, the copyright information of the author and then the license type, in this instance out of Rhino. And there's an interesting thing we'll be going over in a later webinar, which is that the digital file that describes this object, which is a functional object, is covered by copyright by default. So as soon as you produce this object as a digital file, you've authored it, and it's a creative work, and so it's covered by copyright. In normal life, most functional objects are not covered by copyright because you have to apply a patent or a design registration to cover them. There's a weird backwards loophole whereby, because this is a digital file, if you do a physical print from it, that physical print is not covered by a copyright, right? But if someone takes this digital file and prints it, that print is covered by copyright. So then you basically have a legal coverage for that thing. And somebody then scans something they printed and then prints that again, that's also covered as well because they've gone through the process of making the digital file. So it's this weird thing that's happening. We're going to talk about it a bit later, but just be aware there's some loopholes with copyright and files for some reason.
Right. Yeah, and so I don't have the pictures here with me of them being used, but I have them with me so I can show on the camera. One of these pairs I've personally been using for about a year, and they're still holding up really well. So,
do you know anything about the orientation they were printed in?
No. For some of them, you can still see a bit. We had originally asked that they be printed with the flat face down. Also,
for surface or strength reasons?
A bit about for surface, because we also have on this flat face, we also have some like logos and descriptions embedded into the mesh that you can see here. That we wanted to make sure they're clear enough so that also even for us, we have a bunch of prototypes. It helps us to be like, okay, which number was this one or what? As far as strength, we liked NGF versus SLS also because it had in most axes overall similar properties. Yeah. So we didn't go as far as like making sure a certain axis was printed in.
Probably printed this.
You think like this?
The logo came out pretty clean.
I think depending on the part, yeah, I could see on some of the parts the logos were cleaner, on some others it wasn't as clean. So for sure they weren't following like, yeah, I think they were just like batching it, whatever fits.
Yeah.
However it fits, we'll make it fit.
And there is variability in part quality within each bounding box of the machine. So there's,
I think I've seen it
in the
with
middle versus the
also
side, it'll be different.
each service bureau.
Yeah.
So I think this part was printed with one service bureau, this part was printed with another, this part with the same as this one. Yeah, I think depending on the service bureau, we've seen different quality. And so we're still actually exploring different service bureaus we can call out to.
Cool. David, is there anything you want to address on the exporting these complex files, printing, any advice you have as far as nTopology goes?
I would be a little bit biased because we have a lot of things in implicit modeling. So I'd say that like use implicit design tool that can design such complex things first. But I think people still export these as STL without knowing that there will be a huge efficiency achieved when you just export it as DfAM. Even with nTop customers, when you export mesh, you have several options, including OBJ and other mesh type. But STL is still number one by far. 3-4 times bigger than DfAM.
Yeah.
But yeah, DfAM is a little bit more reliable, and you get a lot more compression when you choose DfAM. So
and the 3MF mesh is by default watertight as well, so you don't have the same flipped triangles.
Yes.
Nightmarish stuff.
Yeah, for us, I think it was because we were switching back and forth between softwares. I think STL, we use that as kind of like the back and forth file type. Because, I mean, technicalities, Rhino 7 doesn't import 3MS, but Rhino 8 does. And at the time, the beta wasn't out yet. So it was just a way of doing it because we were applying textures. And then we exported as 3MF as the final kind of output file, which is the ones that are all online and available.
Did you assign the colors in Rhino, or is it just something you did afterwards?
We did all the texturing and everything was done in Rhino.
Okay. And was there any complication in sending the full color print to HP to print in full color? Did you need to have any conversations, or just?
We had conversations, and because we had done prints like that previously, where we had to export as WRL or OBJs, which are just like, it's kind of a nightmare to get the, especially when some of them we were coloring the nodes of each mesh. So you have to find a way to export that as an image file.
Oh yeah, I remember that.
So that's a whole nightmare. So with 3MF, there was, when we talked to the HP guys, they were like, yeah, just do 3MF. And then even for us, it's better. We don't even have to send them the JPEG or anything we're using for texturing. It's just all embedded. And
yeah, I remember at Shapeways when we were doing full color for the first time, and I had to write a tutorial. There was no tutorials on how to print from full color because there was nothing out there yet. And so I wrote this tutorial, and that's a nightmare. And it took me hours to do VRML with a zip folder, and the image had to be in the same folder, subfolder as the file. And then I forgot about it for like a couple of years. I was working on another project, and it's like, oh, how do I export a full color print? And then I was searching up, and all I could find was my own tutorial. I was like, it's terrible.
The interesting thing is now with Rhino 8, when you import a 3MF file, which I've now tried since it came out, the beta, is when you import the file, Rhino will read the mesh and show the mesh, and it will also create the JPEG file in the same folder where the 3MF file is. So anybody who downloads the file wants that texture, or
because texture map.
The texture map is embedded within the file, which is really nice.
We've got our first question up here from Michael Lianek. It's a short question, maybe it hasn't finished yet. So, Michael, have you begun using? And we didn't get the rest of your answer. The question. Have you been using Monolith AI products? Has anyone used Monolith AI?
Is it the same Monolith that came out as a plugin? Like
no, right?
No,
there was a Monolith that got acquired by Autodesk. It was 8 years ago.
Yeah.
This is a different one. No, if anyone has any experience with Monolith AI, I'd be super keen to learn about it because I don't know anyone who's doing the optimized designs. Yeah, it's an optimized design tool. I'm aware of it, but I don't know anyone who's used it yet. So if anyone is using it and wants to reach out to me, I'd be happy to discuss it with them.
Yeah, we'd love, I mean, as a design studio, I think it's one of the things we said in the article we published with One is all these tools like nTop, Rhino, for us, it's like creating our like toolboxes. So we'd love to explore all these new tools, try them out, see how they can improve workflows, or especially for this, it was definitely like a huge improvement for us. So yeah, definitely, I'm going to look into that.
Yeah, cool.
Sure enough.
Yeah, if there's any new tools, just reach out to me via LinkedIn or whatever. And there's a lot of articles I've been writing with people around, it's called designforam.com or DfAM Substack. There's sort of features of people using these kind of softwares and maybe some software reviews coming up soon. So check out that as well. Any other questions?
I have one question.
Oh, yes.
So recently, I think it has gone viral, the chatbot.
Oh, yeah.
Chatbot. Did you try to top the bot out of our dream?
I talked out of 3MF.
Yeah, did you?
I said no.
Yeah.
Andrew Sartorelli tried to get it to write a converter from STL to 3MF, but it had some errors in the text, so we couldn't get it to work yet. But I'm sure it will.
Okay.
In no time. Had to get Nubby STL downloaded or something, which is But it's just a matter of time.
Okay.
The 3MF, I mean, the Chat GPT is pretty good at describing the value of using 3MF above STL. I did a landing page and it's entirely using that. It's not text. I just changed a few words here and there. Oh, well, any more questions? Do you have any questions for Deho on nTop and their export of 3MF and what's up next?
Yeah, we're actually, I'd be very curious if anybody has done, because we're also currently working on some furniture pieces, if anybody has used nTop for furniture.
Our former CEO, he's now a fellow, but Blake Carter, he actually is a woodworking guy, so he has an entire shop at his place. I'm sure he has done designing in nTop and using it for woodworking, but it depends on what you do. So if you do NC machining, yeah, we have feature missing in generating toolpath from nTop. So you have to take the design to somewhere to do the CAN processing.
I think we're currently working on a few furniture pieces done with additive manufacturing. So we've done FDM, pretty large FDM pieces.
Yeah.
And we're looking now to do some other technology, see if we can make it work. So definitely interested in finding a way maybe to use nTop to do that.
Yeah, so maybe that's the next application we should. Yeah, we are looking for more kind of manufacturing techniques and more niche applications that we can apply nTop to. So yeah, definitely something to explore, I guess.
Okay, and one thing I do want to note as far as the design for people who are still on the chat is all the files are available for download online. I can put a link here.
The 3MF files, yeah.
The 3MF files, all the 3MF files, no STLs, I know.
No nTop files or Rhino files?
No Rhino file, no. But they're all available for download. If you have any questions, you can reach out to us on Instagram. We've actually had a lot of great responses on these, and we have a few pro skaters actually interested. So hopefully you'll see some pro skaters trying them on next year. So we're making a few. Let me see. How can I put the link
in the chat?
In the chat here. There you go. That's a Google Drive. You can get all the files in there. And we have which is pretty cool. We have some pro skaters. The guy who's pro skate that Marble Skate is reached out to us, and so
nice.
Hopefully we'll get some people that are way better than us at doing this. Give us feedback and see how we can improve this.
Yeah, cool. Okay, well, we've made our 30 minutes. Thanks everyone for joining.
Thank you, everyone.
Yeah, if you have any questions, ping us via LinkedIn or Instagram or
LinkedIn, Instagram,
all the things.
All the.
And if someone's looking for some help designing products with computational design,
reach out to us.
Manufacturing. Is there an email address they should ping you on?
You can just email us at info@slicelab.com, and I'll put that in the chat as well. We've had projects come through Instagram, projects that come through LinkedIn. It's kind of, in today's age of communication. Twitter, we're not so much on, and I don't think we're going to get on anytime soon.
You're going to link to your own profile soon.
Huh?
You're going to link to your own projects soon.
Oh, really?
No, I'm just making that up. Cool. All right.
I can send our customers to you if they need some projects.
Yeah, well, we'd love to.
Dave, anything you want to close out with?
No, thank you for coming to our new office
Oh, yeah.
in Soho, Manhattan. Although it's not like we just moved in, so it's not.
It's beautiful.
Yeah.
Yeah, it's beautiful.
Yeah, anyone's in New York, they're welcome to come visit the nTop office, of course.
Email me first.
Cool. Okay, we'll end that now. Thanks, everyone. Yeah, reach out if you've got any more questions. And thanks for joining. Really appreciate it. Hope it's been educational, if not entertaining.
Absolutely. I think it's time for beers.
Yeah.
Bye.
Bye.